Hello, hello, welcome to my talk. This is pork, it's not what you expect. This is kind of a multi-dimensional title because one, you didn't really expect me to pronounce it like that. And two, it tells you kind of what the software is if you have any familiarity with expect. So this is a software project I've been working on in my spare time to kind of enable testing for TTY functionality on FreeBSD. Instead of Tickle, it's scripted with Lua. So it's a little bit more friendly and a little bit more consistent with what we write in other parts of the base system. So a little bit about me. I'm currently the FreeBSD engineering manager at Clara. I've been a FreeBSD source committer since 2017. As for this talk specifically, some of the relevant work that I've done, Warner Losh had integrated the Lua loader in 2018, which is where I generally learned Lua to start with. In the next year, I did a lot of work with that, and we got it enabled in time for 12.0. I then pushed for Flua the next year, and we got that added to the build so that we can start rewriting stuff in base in Lua. Then we've since rewritten just a couple of, kind of build tool type stuff, the tool that we use to generate syscall tables, and recently landed a remake for our makeman.sh, which we use to generate source.conf. The main advantage was being able to add parallelization. We did a lot of fork and exec stuff there, and it generally improved it pretty well from, I think on the Mount Snow system I did, it came down from something like 2 minutes to 30 seconds. So that was kind of a significant improvement. I've done other things in FreeBSD, but I kind of work a little bit of everywhere, so it's nothing really significant to put on this kind of slide, at least. Otherwise, I'm not good at pronouncing things, and I'm not good at producing diagrams. So I apologize, and we'll hopefully just get through this together. So today we're going to talk about the motivation, why I bothered writing this in the first place, and why I didn't really think expect was good enough for what I wanted to do. We'll talk a bit about the design and some of the choices that were made to enable the kind of testing I needed to do. And we'll talk about some other kinds of features that I built into it that are also generally kind of useful. And also we'll show some examples. I wanted to do a demo, but the demos aren't very interesting because you just run the script and then get no output, so that it's kind of not very fun to watch. So first, motivation, just diving into the background a little bit. Pretty much every Unixy, POSIX system, you're going to find some kind of pseudo-terminal driver. And this helps us overcome one of the challenges that we'll talk about in the next slide. And we generally, the control side is software-driven to mimic a user so that we don't need to actually physically reproduce these reports and make sure that they don't regress. So terminal canonicalization as well. So when you have generally a program trying to read will only read one line at a time rather than reading every single byte. So the kernel generally does the line splitting and then only returns when we have a whole line blocking in the process. And then the EUF character, which terminates the line or sends an EUF to the program. So if you have, for instance, cat, send the EUF character, then gone. And specifically, the motivation was a single bug we had there and making sure that we had that tested so that someone else doesn't come along and break it again later. That's pretty much it there. So what I wanted was adding tests for the TTY layer. I can fix the bugs that we have, but there's no way to assure that they're not coming back. Nobody is testing much of this stuff on a consistent basis. And I don't really work on TTY stuff all that much, so chances are someone like Christoph could just come along and break it later for us, and we would just never know. And that includes things like this first one here where they had a 6-byte buffer, and you'd type in exactly 6 characters and then hit the EUF key, and then it would read the six characters and then terminate because we didn't eat the end of line that should have been consumed by the line. And that was generally the motivation for this. I also decided when I was kind of looking at what I wanted to write that it'd be useful to be able to do some basic program orchestration, which is also how the name kind of came about. I'm not very creative, so just abbreviation for orchestration seemed like the way to go. And then somewhere in the middle of this, there was a Rust library of the same name that was released, so it ended up getting renamed to PORK, which was program orchestration, which is kind of why I pronounce it a little bit differently. And then I also saw some potential for other interactive program testing, which we have some plans already to do this kind of thing, but we haven't widely deployed it yet. So if you're not that familiar with expect, in their own words, it is programmed dialogue with interactive programs. It's scripted with tcl, which I'm not really fond of. This isn't a thing that I use more than like once a year, so I generally don't want to have to keep referring to manual every time that I need to write it. And Lua, I use much more frequently, and I find it a little bit more friendly in general. So that was obviously a pretty big motivation. Otherwise, it's fairly complex. There's a lot of use cases that expect tries to cover that I didn't really want to care about. And it just didn't really feel like a good fit for what I needed, because I needed to be able to control some other aspects of the TTY. I needed to be able to stall it a little bit while I prepare input for the program to read. And it's also public domain, which kind of poses its own challenges sometimes. So it was much easier to just write my own thing that didn't really have any of these problems. And some of the challenges when you're trying to do some of the TTY testing I wanted to do is we didn't really want to race the program trying to read. I wanted to be able to hold it until I was ready to, for the program to actually try to use the TTY. Some of the test cases we need to write are kind of tedious to generate. Things like, okay, we need to make sure that we need to try to flood the input queue to try to see what it does when it has to queue up more than that. So that's also not very fun to do in some languages. And I wanted an easy way to send control sequences without thinking about it. I wanted, when you read this, I want you to see, okay, I have this char C, I know you're sending a control C. That's just, it's not really a big deal, but it's just a minor readability thing that's kind of important to me. And I wanted to be able to do some of the kinds of things that STTY does so that I can, for instance, disable canonicalization and the other kinds of things that I might want to do. So talking about the design a little bit, it's scripted with Lua, 5.3 and up, mainly because I used some bit operations and I didn't really want to deal with compatibility for earlier than that. FreeBSD's Flua is 5.4, so that's kind of convenient. I don't really need to care about earlier than that, but 5.3 is easy enough to do. It has both a scripted mode and a direct execution mode, which is generally just library usage. It's pretty portable. I tested in CI on FreeBSD, macOS, and Linux. I'd like a solution to do the same for NetBSD and OpenBSD, but right now I settled for just testing it before I cut a release, just to make sure that it didn't regress. Normally I don't really have any problems with that. It just kind of works. The test suite does need at least NetBSD 10 because I needed the RealPath program. I didn't really feel like working around that. And OpenBSD and NetBSD both fail one minor test because they're missing the capital S for env to do word splitting, because the file name needs to go to the -farg instead of the first non-option argument. So the kind of process flow that this generally has, so you spawn an application, and when you spawn it, we don't actually execute it immediately. It sits in process hold, which we'll talk a little bit more about in a minute. And then from the user perspective, you then go into a write match cycle until you are done with your test, and then you send it to end of file and you close it out. Kind of deeper look into that. So that process hold is sitting, the process is sitting post fork pre-exec, and it just kind of waits so that we can send it IPC. This is where we can configure different things about the TTY, or we can configure different signal handling. And only some of that really needs to be done at this point. This is also where we may buffer up input so that we can make sure that it's all there before the program has a chance to try to read it. From there, the program gets released, either implicitly or explicitly. If you try to do something that would otherwise block if the program's not running, then it'll just go ahead and release it because that's clearly what you meant to do. And then it goes into the run state, which lines up with the previous write match cycle there. Until you close it, ideally, it just closes cleanly, no problem. If not, we'll send it to sigterm. Previously, that was a sigint, but I decided that was kind of a dumb idea, and I don't know why I did that in the first place. And then if it still hasn't died after 5 seconds, we'll send it to sigkill just to make sure that it's actually gone. When it's in the release or pre-release state, you can configure different things about it. The only one that you actually have to configure at that time are signal mask and signals that are ignored or caught, just because we can't do that without more magic once it's no longer in our control. Otherwise, you can configure different timeouts, write speeds, which is also kind of borrowed from expect. You can configure most term IO settings. So any C flag, I flag, L flag, or O flag you can set, as well as control characters. You can also change the window size, which is maybe a little bit weird, but at Clara we did I don't remember if we had implemented it or improved it, sig winch handling in script. So I wanted to be able to test what happens if we resize the terminal as we're writing to it. And so that kind of motivated that one. It was fairly easy to do once we already had other term IO stuff we were working on. So it seemed like a reasonable thing to do. The scripted mode, these are org scripts. It's a very limited environment. So it reads the script, everything you can execute. It's generally in a limited sandbox, and everything will more or less create an action that it enqueues for later. You can still generally write arbitrary Lua, and it's still Lua, but it's a little more complicated. You have to think about exactly what's executing right now and what's going to execute after everything starts running. There's some things I've done to be able to paper over some of the differences so that it's really not that bad. In scripted mode, you get one process at a time. So you spawn the process, you can operate on it. If you try to spawn another one, we're going to kill the first one. We don't need that kind of complication in our life. If you feel like you need multiple processes, that's kind of what the lib mode is for. And we also kill it when the script ends, so that we're not just leaking, things like that. As far as actions go, we have a number of things that you can do in scripted mode. We won't really talk about all of these, but like we had said before, you can configure the write delay. We have several options for configuring signal. Signal masks, or what's ignored, what's caught. You can send signals to the process once it's running. This is useful for things like Unix conformance testing or testing specified behavior, because you may need to get to a prompt and then send it sigint and try to observe how it responds a little bit. It can operate in the environment. There's also an option to pipe in from another program, which is kind of neat if you need to, for instance, read secrets from somewhere else. For instance, maybe a password prompt. That's a good option for that if you need to avoid putting any secrets into your script. And we'll talk about some of these in a little more depth. There's also, by default, when you're doing matches, it uses Lua expressions, which aren't necessarily the most intuitive. So there are options to switch it to other matchers. You can either just do plain text matching, or you can even use POSIX EREs, which are a little more natural feeling, in my opinion. So match and one are the basic primitives that you're working with. So match is the basic pattern match. You can do multiple patterns in a single match, and the earliest, longest match wins. The earlier version of this was the one multiplexer, which takes a callback in a series of matches, and it's really not very elegant feeling. The first one to match wins, so it's kind of ugly, maybe not the most predictable thing in the world. One came first, and then multi-match came later, so one might get deprecated, but multi-match will stick around. So exec allows you to execute arbitrary commands. This one was also motivated kind of by conformance requirements, because we need to be able to, for instance, in the case of mailx, we need to see if it left dead letter around after the program is terminated, and I don't expose any IO operations to the sandbox, just because I don't really see a need for that, and I think it would complicate things. So you could, for instance, use exec to execute test, and then see how that terminates to kind of be able to test that. That in some instances, depending on where that's located, that might complicate things a little bit more, since anything done as a result of executing. So you execute it, a callback is invoked, inspect the wait status, but you can't really do anything with that immediately after that's returned. So you'd have to enqueue another block in order to do anything with that. It's a little bit ugly, but in the case of something like mailx, it's okay, at the end of the program, I'm just going to check if it's there. I'll look at the exit status, and then I'm terminating either way in the callback for exec. So it kind of works out that way. And it could also be used for kicking off other activities that are maybe needed in the process. Pipe. This one is basically the same thing as exec, except instead you wire up standard out of what you're execing to the process that we spawned. So we p-open it, we read line by line. The script can apply a filter if it wants. So I don't really know what kind of things you may want to filter, but you can, and that's somewhat useful. And then it just writes them to the process. It's kind of useful if you need to do things like execute something else in order to, for instance, collect a password or something, as I had mentioned earlier. It might also just be for general fetching data from the disk. As mentioned, IO is not available in the sandbox. And generally in the sandbox, you don't really have much of Lua. You have string functions, table functions, and that's pretty much it. Nothing else has been really useful in any of the scripts I've written. So as mentioned, signal handling, this was kind of inspired by conformance requirements. mailx specifically was the last one we dealt with. We've dealt with other ones in the past, but this was the most convenient example. And in the case of mailx, you get to the prompt, Control-C, interrupt one more to exit, send another one, see if dead letter exists. I have that as an example in the repository. We had already written a test in C for this, so I don't think that there's any point in deploying pork for that today, but it is an option if we need it. We can do pretty much everything we would need to do with the signal mask, and we can also ignore signals if we need to. It otherwise doesn't really touch the mask or anything coming in. So if you have any dependencies on any certain signal state going in, then you do need to actually set that up yourself. As far as debugability concerns, it's because of the kind of weird nature of the scripts you're processing. I wanted to do something to try to make it a little bit easier to figure out what went wrong. So there's a fail callback that when a match actually fails, it'll invoke the callback with the remainder of the buffer so that you can write that out and try to understand exactly where you were. It's especially useful since you don't get any kind of output when it's running. It's fairly opaque in general. If you don't install a fail handler, then it just prints out some diagnostics, line number, basic information like that about the action we were trying to run, just to try to give you a hint of what you need to do next. And it also has debug and hex dump functions for outputting. So the direct execution mode was kind of inspired by Mark Johnston, because he actually deployed this in his testing tool called bectl. I think he's my only user, and he's talking about switching to Python. So that's we'll deal with that when it happens. But so in the lib version, you have a run script that you can use to just run a script, or you can spawn processes off with this. Pork.spawn actually returns a process object that you can do basically everything we had mentioned in the scripted slides. It retains all of the signal and terminal configuration functionality, but it also adds a bunch of sig.is functions that can be used to check the current status of all of that, since you're no longer operating in the kind of weird queued mode. So it's not anywhere near as limited. And this one will also terminate the process as soon as you try to close it for convenience. The notable difference between this and scripted mode is that there's no one action, only multi-match. It's kind of reflecting my desire to kill the one action, which I probably should have done a while ago, but maybe someday. And otherwise, it follows the exact same model. You write match to drive the process to completion, and you can also do other things like check the exit status, see if it was signaled or whatnot. And you can actually spawn multiple processes if you're using the library, so that's kind of convenient. One of my desires that I mentioned later is to kind of abstract out some of the IPC bits so that it's not all quite as tied to Lua, and then maybe write a Python version, just because I think that could be useful, especially with the blocking nature. I think that's a little bit handier than expect, and that could be a nice addition. It's not really on the roadmap anytime soon, though. As for scripted versus direct usage, scripted usage was primarily intended for testing things. So this is what I would mainly use it for in, say, FreeBSD, for instance, while the lib mode was intended for arbitrary things. I didn't want to add the whole kitchen sink to it. So when I added it, I figured that anything else that someone wanted to add, they could just wrap the library, and then that's their problem to deal with, not mine. And I was picturing things like if someone wanted a mode where they can run it and actually have the user interact with it at the same time, or be able to interrupt themselves, that's the kind of thing you would use the lib for. So other things I added, I had a small talk with ChatGPT. Most of what it had for me was crap. Frankly, it had maybe 20% of its ideas were actually reasonable, and then I kind of beat them into something that kind of made sense. So the first one I had was porkgen, which is generally just for creating pork scripts. So it launches a program, it proxies its output to standard out, and then as you interact with it, it generates match and write statements, and passes your input through to the application. It does leave some previous match context just in case we got it wrong. Maybe, for instance, I thought you were responding to this, but you were actually trying to respond 3 lines up. So that's kind of handy. It's kind of expected that you will need to review and edit the output a little bit, but it at least gives you a nice start to a script rather than having to write the whole thing from scratch. So RPORK, it's the R for remote, kind of self-explanatory there. It's just another executor. It executes the script locally, as you might expect, but every spawn command in the script is executed via the RSH program, which defaults to SSH. So this is kind of useful if you maybe design it for local testing, but you also want to try it on a different machine. So you can just use RPORK and easily connect to a different host and just drive it all there. I mainly think of things like maybe I have a menu or something that I want to test on a remote device, say appliance or something. This kind of thing that I could do pretty easily with this. And it does do word splitting of the RSH program, kind of inspired by rsync. So that you can pass arguments to SSH rather than having to write a wrapper script if you need to do anything even moderately complex. So that's kind of nice. Another idea I had that I'm a little more interested in, but it's more complicated to manage, is pork Fuzz, which doesn't sound very pleasant, but it's again exactly as it sounds though. Fuzz testing application input handling. I wasn't really sure of the best approach, but I kind of landed on something like you drive the program with write and match, and then eventually you just, instead of calling write, you call Fuzz, and then we cooperate with something to actually fuzz the program. But this isn't really how fuzzers today work. What would be nice is something like AFL that has a server and then I can cooperate with it to launch the program so that I can still take advantage of some of the instrumentation that it would have done, but I can be consuming the input in pork instead. But that's not really how it works today. So I'm not really sure how to implement something like this, but I would like to, and that's maybe a long-term goal. You can otherwise obviously just do your own kind of fuzzing, but it's not really as effective as the instrumentation-based stuff. So looking at some examples, this one is getting lonely one night, set up netcat, listening on port 9999, and talking to myself with this. So as soon as it connects, it writes hello from the other side, and it matches anything and then talks back. So a nice little conversation with yourself, which is not really a useful example, but it kind of demonstrates what I think is a little bit of the elegance of Lua and writing something like this. So that's that example. This multi-match, which also isn't considerably more complicated. So this one is an example that you're intended to play with a little bit. You exec cat. So the first write generally dictates the path you're taking, and kind of a useful example to play around with the semantics there and get a feeling for how that generally works. So also not really a practical example, but something that can be useful to play with. And this one is one that we've actually deployed in FreeBSD. So this is some part of the testing that I was talking about earlier. So in this case, I've parameterized 8, 9 tests to this read size program that I wrote to make sure that we're getting file and read write for all of the different input. And I feel like this is a very powerful thing in general. This would have taken me a lot more C to write than just that amount, for sure. And that's more or less it. As far as future work, I'd like to write more tests for interactive stuff in base. Right now we have the test for TTY stuff that I mentioned earlier. And we also have some basic, one test for T that I use it in, mostly for convenience, because you can stall the input to T, but it's much nicer if you can just have this TTY that you're not writing to and then send it as sigint. Then the libpork and Python interface I think would still be kind of nice to do, because Python can be more enjoyable sometimes. And then pork fuzz, as I had previously mentioned. And then that's it. Any questions? Perfect. Thank you.